All right, next topic for this first part of the week is prime numbers and composite numbers. So a lot of the stuff, like, it's I've taught a couple of you in the course, and so you forget about what people know, what they don't know. So just use these as tools for me, please. So factors are what we can multiply to get to a number. For example, the factors of 8 are 1, 2, 4, and 8, right? So 1 times 8 is 8, 2 times 4 is 8. So those are the factors of 8. Sometimes people write out factors by like thinking about them and saying like, I have 8 could be, sorry, not equal sign, but a colon. I could be 1 and 8 and 2 and 4. And then 3, nope. 4, I'm back where I started. So that's one, that's kind of one way people think about factors, right? For multiples, that's going to be the numbers as we multiply them up. So we have 3 times 1 that's times 1 gives me 3. 3 times 2 gives me 6. 3 times 3 gives me 9. 3 times 4 gives me 12. 3 times 5 gives me 15, and so forth and so on. So that's just a quick vocabulary review before we move on to the next slide. All right, so on the next slide, oops, sorry about that. Clear, pen, clear, lots of things to click. Are prime and composite numbers. And so that's really what the factors come into play, because we have to think about like our factors to be able to know whether or not a number is prime or not. And then you also think about multiples to be able to determine whether or not you what the factors are essentially to be able to get to a particular problem. So composite. A composite number is a number that may have more than 2 factors. And so, like, for example, we have 8 we already looked at. Let's look at another one. Like, for example, let's do 25. Because 25 is 1 and 25. 2 doesn't go. 3 doesn't go. 4 doesn't go. 5 goes. And that's it, because 5 and 5. All right? Maybe 15. 15, because 1 and 15. 2, no. 3, yep. 3 and 5, and that closes it out. So those are composite numbers. The opposite of composite number in the real number system that we're working in are prime numbers. Prime numbers are prime because they don't have any other factors besides the number 1 in themselves. So like, for example, 17 is prime. 2 is prime. Even though it's an even number, 2 is prime because the factors of 2 are 1 and 2. 3 is prime because it's 1 and 3. 5 is prime because it's 1 and 5, etc., etc. However, please note that 1 is not a prime number. All right, it's kind of just special, kind of standing on its own. So what I wanted to introduce to you is I have what my intentions were with this is that you'd be watching this video and you just do a QR code of that guy right there. I'll include the link in the assignment so if you just want to do it a different way, you can. So let me clear this, do this, and then I'm going to back out of here and show you this other site real quickly. So the QR code will take you to this. All this is doing is allowing you to kind of like test yourself to see whether or not like you remember what the difference is between prime and composite. So you look at the list here, you're like, oh, no, 18 because you can do 2 and 9, 20, 2 and 10, 21, 3 and 7. So as long as it's any other factor besides 1 in itself, then we know that 19 would be the prime. And so you can go on to the next question. And there's just a few questions for you to try to review. All right, I won't keep on working questions, but like I said, just kind of test your knowledge on prime and composites. This is not an assignment. It's only a tool for you to use. All right, let's go back to the slideshow. So now we have a method actually that helps us identify whether or not numbers are prime. And this is called the Sieve of Eratosthenes. I probably said that wrong because I'm terrible with my grammar, my English, but let's walk through how this works. So this is kind of cool because this is actually something I've never actually used before. And so this is just thrown in here. I guess it's kind of cool. I can see how I would use this if I was teaching my middle school math class, maybe primes and composites. I guess, I feel like this topic would be kind of tricky to introduce it this way with elementary school kids, but they might get a kick out of it. Like the whole process of understanding this table might be the cool part. So first thing we do is we have our numbers listed. They select the first prime number. Remember that 1 is not prime, so 1's kind of off the list, all right? So we are going to circle our first prime number. So that's 2. and then cross out all its multiples. This is where the multiples come into play. So 4, 6, 8, 10, 12, 14. I'll hit pause. You finish doing that and come back with me, okay? All right, welcome back. All right, so we have all of our, we have our first prime number, which is 2, and all of its multiples crossed off. Now, why would the multiple be crossed off? Because if 4 is a multiple of 2, that means that 2 is a factor of 4, right? 2 times 2 is 4. If 6 is a multiple of 2, that means that 2 is a factor of 6, therefore 6 is not prime. So what we're trying to do is identify all the prime numbers. All right, so the next one is, our next prime number is 3. So following the process, it says select the next prime number, not crossed out, which is prime. So I circle that, because I want my prime numbers to kind of stand out, right? So I circle that guy, and then the directions is to cross off all the multiples, all right? So some of them are already crossed off. So if they're already crossed off, you don't have to cross them off again, or you can double cross off. Since I'm using colors, I'm going to double cross off. I'm going to hit pause, cross off the multiples of 3, and come back when you're done. All right, welcome back. Let's talk about this. So determining the divisibility. So this is kind of a little side. Divisibility. Hooked on phonics, right? So divisibility of 3. So divisibility of 3 has a cool little trick. So the nice thing about this table, and why this might be really neat for you to use this in a classroom setting as a teacher, is that, you know, like the kids don't actually have to know the multiples of 3. They can just say 3, 1, 2, 3, 6, 1, 2, 3, 9, 1, 2, 3, 12. So every third one, they're going to get there. Now, the other cool thing you can teach them is the divisibility rules at the same time. To kind of like just expand them. Some kids won't get it. Some kids will grasp right onto it. So like, for example, let's take 18. So the rule of divisibility. So 18. 18 is 1 plus 8, which is equal to 9. So the divisibility rule says that if you can take the digits and add them together, if the sum of the digits is divisible by 3, then the number is divisible by 3. So 9 is divisible by 3, so therefore 18 is divisible by 3. Let's try another one, 48. So that's 4 plus 8, which is equal to 12. 12 is divisible by 3, so is 48. Check, we got it. Like when I got up here and I was like crossing off 51, I was like, 51? I don't know the factors of 51. So I tested it. 5 plus 1 is equal to 6. Dang, sure enough. I don't know what multiply by 3 to get to 51 off the top of my head, but I know that 6 is divided by 3, so therefore 51 is divided by 3. So that's a cool divisibility rule also to think about. All right, so let's continue the process. So now our next number is, let's see, does yellow show up in this? Yeah, that'll work, is 5. So circle 5, go through and cross off all your multiples of 5, and then come back when you're done. Awesome, welcome back. So divisibility rules of 5, most of our kids already know that. That's kind of like the first one, but now we have divisibility of 5, and that's going to be if it ends in a 0 or a 5, right? And the kids, you know, that's kind of like your first initial one. Most kids come born with that one inbred. Not really, but just, you know, just kidding around. So next one, let's go. Green is 7. All right, so 7's a little bit trickier. You know, there's really not a solid divisibility rule for 7. And so it might take you a little bit longer. So we can just get that idea of like multiplication. They could look at their multiplication chart to figure that out, whatever it is. And so give me 1 second. I'm just going to double check my thought process on this. I'll be right back. All right, sorry about that. I changed my colors when I went to remind myself of the rules of 7. I messed up. So hopefully you took the notes on that. So for 7, slightly different scenario. A little bit harder to remember. Maybe you introduce this really briefly to some kids, they'll tie on to it. Like other kids, this would probably be a challenging. Like I don't remember it, so that's why I had to look it up. So like for example, let's take 49. So we know that's a factor of a multiple of 7. So what we do is we take the ones digit. So we take this guy. So we take 9 times 2, right? And so 9 times 2 is 18. And I just did something wrong. That's interesting. I'm going to keep this video rolling. I'm just going to figure out what we did wrong here, or what I did wrong. You guys didn't do anything wrong. So we double that. So 49 is definitely a factor. Oh, no, that's right. So 49, and then we subtract. So that's 18. But when I take 14, oh, yeah, that works. So that's a factor of 7. All right, so let's try another one. Let's try 56. So 6 times 2 is 12. When we subtract that, we get 7. So that means that since that's a factor, 7 is a factor of 14, so 7 would go into 49. 7 is a factor of 7, so 7 would go into 56. Let's try one more. Let's go 77. So with 77, we take 7 times 2. Remember, we're taking the ones digit times 2. That gives us 14. Then we subtract that from the other digits. So now this one digit is like gone. We subtract, even though we're subtracting, we get -7. It doesn't matter. It's still a factor, right? It's still a multiple. It's just times a negative value. So sure enough, so we tested numbers that we know it does work for. So now we found the multiples. So what we want to do is test one that doesn't work for. So let's try that. So let's try 59. Right? So 59. Is 7 a factor of 59? And so we say 9 times 2, that's 18, right? And then we take the 18 away from the 5. And 5 take away 18 is 13 or -13. And 7 is not a factor of 13, so that doesn't work. All right, so we're going to go through and cross out all the factors of 7. Let me hit pause real quickly. I just want to make sure I get it right the first time through. I'm going to cheat and use my calculator. Go ahead and cross off your factors, or I'm sorry, your multiples of 7, please. And then hit pause and come back when you're ready to go. All right, welcome back. So go through and double check the numbers you still have listed are there. At this point, we get to this spot where we're like, okay, well, do we keep going with with 11? And we could, because at some point we're going to reach a point of saturation. So go ahead and stop for a minute and let's fill in. Now take your next one, which is 11. So we circle it, right? And go through and cross off your 11s. Then go through and cross off your 13 multiples and so forth and see what we start to see. All right. Come on back once you got your final thing figured out. All right. So we got this spot where, we basically know from our experiences in life at this point, we do, that 11, 13, 17, 19, and some of you maybe can go further with that and identify, 23 is prime, 29 is prime, 31 is prime, 37 is prime, 41, 43, 47, 53 and 59, 61 and 67, 71 and 73 and 79, 83 and 89, and 97. So these lower ones, we kind of have experiences, right? But for the kids, this kind of creates a scenario. So this is kind of a cool activity. So now we can use this to be able to go through this process of applying a few other ones. So I'm going to go ahead and hit clear real quickly. Let me hit pause and I'll be right back. All right, so in your actual activities for the week, you'll have some situations that would be identifying prime versus